Hello friends, I am Hemadri. I am working as assistant professor in the Department of Mechanical Engineering in RMK College of Engineering and Technology. So today I am going to discuss about heat treatment process. In this we will see the hardening process and the Jominy End Quench test and tempering process. So these topics today we will discuss. First one is hardening process. So what is meant by hardening means, so for after manufacturing the components, example like gear, all these components, we have to improve the hardness level, then only it will withstand some sudden shock loads, and then it will have high strength. So that's why we will do the hardening process. So here in the hardening process, above the this upper critical temperature, we have to heat the steel up to this temperature, and then slowly we will cool this. So above upper critical we have to heat up to 30 to 50 degrees centigrade, and waiting for some time, then we can cool it in different quenching mediums like water, oil or salt baths. So mainly the hardening is required for like gear components and machining products. So all these components we have to increase the hardness level. So here mainly it will depends on the chemical composition also. For plain carbon steel, only it will depend on the carbon content. For a hypoelectric steels, we have to heat up to 30 to 50 above upper critical. For a eutectoid and hypereutectoid, we have to heat up to 30 to 50 above lower critical temperature. For eutectoid and hypereutectoid steels. So this is called hardening process. So we have to apply this hardening process to, especially for, I told you already about cutting tools and the machine parts. We have to increase the hardness level and wear resistance. So here the process variables, mainly the hardening, it will depends on the three process variables. First one is hardening temperature. So once you are heating the steel up to this austenizing temperature, so entirely it will convert to austenite, and then slowly we are cooling, so that austenite structure it will be converted to give the different structures like martensite or perlite like this. Suppose if temperature is very high, it will get the low hardness due to a coarse grained structure. So that's why temperature it will play the vital role. And then soaking time. So we have to wait for some time after heating the material to high temperature. So we have to give some time for transformation. So next is quenching. So we are having the various quenching mediums. So we can choose correct quenching medium as per your requirements, and then we can do the quenching process. So we will take some delay in the quenching, it will reduce the hardness. So this also play a vital role. So now we will see the hardenability. So how to find the hardenability? First we know what is meant by hardenability. Hardenability means it is a quantitative measure of at which hardness value we have to find out. It will be decreases from the surface due to this martensite content. So we have to find the how the hardness value will vary from surface to one end to another end. So for this we have to Jominy End Quench test. By using this quench test, we can find the hardenability of a steel. So first I will explain the procedure. We can take the steel of a standard diameter 25 mm, 100 mm length. We can heat up to some temperature and then entirely it will be converted into austenite. Then you can be take some water pipe, that is water pipe, with maintain the some distance between the water pipe and this steel. From here we can slash the water through this bottom end of the specimen, so we can fix the specimen in fixture. So continuously you are spraying the water here. So here the distance from this quenching end, so at this end the cooling rate is very high. Parallelly the hardness also will increase. So why means, so it will be cooling very fast, because of this hardness value also very high. So then slowly it will be cooling to other end, it will take some time. So now after cooling we can take this specimen at 0.6 mm distance or 1.2 mm distance. You can find the hardness value from the Rockwell hardness or Brenner hardness. You can measure the hardness value. So then you can draw the curve between Rockwell hardness value versus distance from quenching end. So that quenching end distance. So we can measure the hardness. So it will be coming like this. So we can draw all this, can connect all the points. It will be showing like this curve. So here starting at this, from the starting end the cooling rate is very high and then hardness also very high, and then slowly it will be from this end to this end, automatically the hardness value also very low and then cooling rate also very low. So from this we can find the at any point, so what is the hardness value. So this is about Jominy End Quench test. So by using this test we can find the hardenability of a steel. So next process is tempering process. So here in tempering, after a hardening again we have to do the tempering process. So why means, so in a hardening process, so the hardness value is high but it will reduce the ductility. Why means, so final structure in hardening it will form the martensite structure. So because of this the ductility it will be low. So now again we can do the tempering process. You can increase the ductility of a steel and automatically slightly it will reduce the hardness and strength. So this will be very useful for sheet metal operations, for sheets, wires and all. They can do this tempering process. We can increase the toughness also. Toughness we can increase. So here example, if we the head of a hammer, you can take the hammer. So the head of the hammer it will be quenched, it will be converted to fully martensite structure. So continuously you can use this hammer. After some few period of time it will be coming some cracks, but you can do the tempering process. It will resist this shock resistance and then it will have the high shock resistance and it will reduce the hardness value. So normally tempering process we will have the three slab classifications: low temperature tempering, medium temperature tempering and high temperature tempering. So based on the temperature ranges we have given the three classifications. So this is about tempering process. So today we have seen about and hardening process and then tempering process. Thank you.